Picture this. You open up your editor, fire off a vague request to your AI assistant, and boom, it spits out this massive block of code. You confidently paste it in, hit run, and it only half works, right? So you ask the AI to fix the bug, but that patch ends up breaking something else completely. Suddenly, you're trapped in this chaotic 3-hour debugging loop. Look, speaking as a veteran engineer, that is a trap. It's literally a slot machine. But today, in this explainer, we're looking at a total game changer called the PUDO code system. It's specifically designed to break you out of that endless loop and transform your AI from a random slot machine into a precision engineering tool.
And just like the methodology we're about to explore, we're keeping things highly structured today. We'll be moving through 6 main parts. First, chaos coding versus PUDO. Then, the 4-step PUDO cycle itself. After that, real-world API integration, optimizing source code, setting up AI environments, and finally, the core AI native philosophy.
Okay, let's dive into part 1, chaos coding versus PUDO.
To really get why this is a paradigm shift, we've got to look at the stark contrast here. Chaos coding relies on these vague, linear requests. It basically treats AI like some magical crystal ball. Without any guardrails, using AI just turns into a random walk through your codebase, which leads straight into those endless fixing loops we all hate. On the flip side, the PUDO method, which stands for Plan, Understand, Develop, Optimize, replaces all that improvisation with a repeatable, structured cycle. This is exactly the kind of precision engineering tool that professional teams desperately need to maintain control and code quality.
Here's the thing. The core issue isn't actually the AI itself. We love to blame the language model when it hallucinates a non-existent endpoint or makes up a library, right? But the AI isn't inherently flawed. It just desperately needs a structured operating system to give you consistent results. It needs clear constraints. Structure is literally what drives performance here.
Moving right along to part 2, the 4-step PUDO cycle. Let's break down this framework.
Let's break down the exact division of labor here. This is absolutely crucial. It's not just AI does everything. In the plan phase, you set the scope and constraints. The AI drafts the plan and finds risks. In the understand phase, you point it to the source code and context, and the AI maps the dependencies. During develop, the AI actually writes the code and tracks progress while you review and test. And finally, in optimize, the AI refactors and benchmarks while you validate and merge. It's a true, balanced human-AI pair programming setup.
And you have to remember this golden rule. PUDO is a cycle, not a one-way pipeline. The iterative nature of this framework is the whole point. So if you're in the develop phase and you hit a roadblock, maybe a missing dependency or a technical hurdle, don't just blindly push forward. It is perfectly normal and honestly encouraged to loop right back to the plan phase to redefine your constraints and fix the root of the problem.
Let's ground this theory in part 3, real-world API integration.
So how does this actually play out in the trenches? Well, for beginners building a simple landing page, sticking to the plan phase stops scope creep dead in its tracks. For advanced production bugs, running the full cycle prevents those nasty regressions. But let's zoom in on that intermediate scenario, integrating the Stripe API, because this is where the methodology really shines.
Put yourself in the shoes of a totally relieved software engineer for a second. If you've ever tried to integrate a payment gateway like Stripe using AI without doing the research first, you know it's an absolute nightmare. But by forcing the understand phase, where you point the AI and say, hey, here's the user model, here's the current checkout flow, analyze this first, you let it map all those dependencies out. That one little step prevents massive headaches, broken flows, and saves you countless hours of debugging time.
Which brings us to a critical, often skipped step in part 4, optimizing source code.
Look, it is so tempting when you see the AI generate working code to just push it straight to production. Do not do that. Seriously, never ship the first draft. The optimize phase demands strict exit criteria to guarantee final code quality. You absolutely must validate the improvements, carefully merge the changes, have the AI refactor the code for readability, and benchmark performance using your testing tools. Maintaining the integrity of this phase is non-negotiable for a healthy, long-term project.
Now, if managing all these phases sounds a bit intimidating, don't sweat it. The PUDO GitHub repository actually ships with exactly 16 ready-to-use prompts. It's super simple. You just identify which phase of the project you're in or what specific skill you need, like debugging or DevOps, and you pick the corresponding prompt. The system has already done the heavy lifting, so you never have to guess how to format your requests to keep the cycle going.
Section 5. Setting up AI environments. This is where we move from abstract theory to daily action. You don't have to consciously remember the PUDO cycle every single time you type. You can just bake this methodology right into your daily IDEs. If you're using Claude projects, paste the guidelines into your custom instructions. In Cursor, literally just copy it to your .cursor rules file in the root directory. This setup is a massive win for small programming teams. By setting it up once, you establish a standardized baseline. Every time the AI spins up, it already knows it needs to plan, understand, develop, and optimize.
Finally, Part 6, the core AI native philosophy.
If you're a team lead trying to standardize your development process, this is the AI native mindset you absolutely need to adopt. It's fundamentally anti-chaos, proving that structure always beats improvisation at scale. It embraces continuous iteration and ditches the old waterfall method. It recognizes that modern coding is a tight human and AI pair programming relationship. And most importantly, it relies on phase integrity. For large projects, ensuring everyone meets strict entry and exit criteria is the only way to prevent your code base from degrading over time.
The creators of this system summed it all up with a really punchy, memorable message. Stop vibing, start PUDOing. I love that. Relying on vibes or just winging it with AI is a recipe for disaster, especially as your projects scale up. In an AI-driven world, structure and discipline will always outperform improvisation. That is what safely delivers your product to the users. So, the next time you open your editor and get ready to ask your AI for help, I want you to pause for just a second. Are you going to kick off another random walk into chaos? Or are you going to plan, understand, develop, and optimize? Take back control of your development process today by adopting a systematic mindset. Thanks for joining me on this explainer, and happy and highly structured coding.